This is number 39 from chapter 2 in your final review. It's dealing with graphing rational functions. So, in order to graph, you first need to find all these things. The domain, vertical asymptotes, holes, horizontal or oblique asymptotes, intercepts, and then figure out does it cross. So the first thing you would want to do anytime you're trying to graph a rational function is start by factoring out both the top and the bottom of your fraction. So on the top, the only thing I can do is they both have an x in common. So I'm going to take out an x and then I'd be left with an x minus 5. Okay. Then you're going to factor out the bottom. Well, this has 3 terms, but it's not a quadratic. And it's not a quadratic in disguise. So then you look for, is there anything I can take out of everything? So this is x cubed, x squared, and 6x. So I can take out an x again. So then I'd be left with x squared plus x minus 6. And then we want to see if we can factor this bottom a little bit more. We know our top is completely factored. Well, I still have this x, and then this is a quadratic, so I can just factor like a normal quadratic. So you ask yourself, what multiplies up to negative 6, but adds up to 1? So I'll set up my parentheses. Something that multiplies up to negative 6 and adds up to 1 is positive 3 and negative 2. So that's the factored out version of my original function. So then my domain, remember, there's only 2 places my domain can go wrong. It's having a negative underneath of a radical and then dividing by 0. So here, since I don't have any radicals, I don't have to worry about that. But I do have a division, so I got to make sure there's never be equal to 0 on the bottom. Well, if I look at this point, sorry, I'm so tired. This part of the equation, if x is 0, it screws stuff up. So I know it can't be 0 because that would result in the bottom all being 0. And I can't divide by 0, so it's all real numbers except for 0. This, if I plug in negative 3 here, I get negative 3 times, or plus 3 is 0, times whatever this is, times whatever this is, so that'll be 0. So it can't be negative 3. And then this would give me a root of 2. So those are the 3 numbers that would make the bottom of my fraction equal to 0. And we can't divide by 0, it's undefined. So those are the 3 numbers that cannot be my domain. So you write it's all real numbers minus the set of negative 3, 0, and 2, because those break it. Then if you look at this, our x's would cancel out. So that means I have a hole at whatever that root was. Well, it's 0. So I have a hole at 0, comma. To figure that out, well, my new equation, x minus 5 divided by x plus 3 times x minus 2. Well, I know this equation is going to look exactly like this equation, except at that one spot where there's a hole. So what I can do then is plug in 0. So 0 minus 5 is negative 5. 0 plus 3 is 3. 0 minus 2 is negative 2. So then I get negative 5 divided by negative 6, because 3 times negative 2 is 6. A negative divided by a negative is a positive. So 5, 6, so that means my hole is at 0, comma 5, 6. And then anything that still remains on the bottom becomes a vertical asymptote because x still cannot be those values. So that means I have a vertical asymptote at x equals negative 3 and x equals 2. Then I can look for horizontal or oblique. Remember, that's the same exact thing as saying your end behavior. So as x gets really big or really small. And in class, we talked a lot about, well, when we get really, really big, this x squared goes pretty fast, and in comparison, this 5x doesn't grow at all. So we can ignore that. So I'd get x squared over, again here, this grows hugely fast. In comparison, these two things barely grow, so it would be over x cubed. And then that simplifies to 1 over x. So then if you think about it, again, our end behaviors can be modeled as a limit, so the limit as x approaches infinity of 1 over x. Well, as x gets bigger and bigger, I get 1 divided by 10, 1 divided by 100, 1 divided by 1,000, a million, a trillion. This keeps getting smaller and smaller and smaller. So it's going towards 0. So that means I have an asymptote at y equals 0. And actually, that's always going to happen anytime it's smaller on top and bigger on the bottom. Okay? Then for my intercepts, to find my x-intercepts, I set y equal to 0 and solve. Okay? So again, I set y equal to 0. If I multiply all this over, I get 0 equals x squared minus 5x. I'd have to factor that to solve. So then I'd get x equals 0 and x equals 5. But 0 is a problem because it's not my domain. So that's actually not an intercept. So my intercept is when y is 0. Oh, you can't even see that. Sorry, guys. When y was 0, x is equal to 5. So 5 comma 0 is my y-intercept. Again, this doesn't count because it was not my domain. So then to find your x-intercepts, you set y equal to 0. So if I do that, I get 0 squared minus 5 times 0 is 0. So I get 0 divided by 0. That doesn't work. So my only intercept then is 5 comma 0. Sorry, I got a message and I gotta check it because my mom is in the hospital. Sorry, just a second. Okay. Then to figure out, does f of x cross my asymptote? You take your horizontal asymptote and you set it equal to f of x. Because if they cross, that means I have this horizontal asymptote and my function. That means they would be equal at some point. So my horizontal asymptote is 0. And this looks vaguely familiar. We just solved this. It was when we solved the asymptote. So yes, it does at 5. Okay. So then we go to graph this. We got to keep all of that stuff in mind. And I'm going to make a little sketch right here. Sorry, it's not very organized. My brain's kind of scattered today. Here's my intercepts. So again, I know I have a vertical asymptote at -3. So I'm going to draw that here. And I have another one at 2. Okay. So those are done. Check done. Then I have a hole at 0, 5, 6. So here's 0, 5, 6 is a little less than 1. So I'm just going to draw a hole there. Okay. Check and done. I have a horizontal asymptote at y equals 0, so draw that in. Woo, check done. I have an intercept at 5, 0. So 1, 2, 3, 4, 5. So it's going to cross right here. And check done. I know it crossed at 5, which I already did. Now for the little game we'd have to play. So I know there's a hole here, and I know it doesn't cross my x-axis anywhere here. So I can't come from below because then I'd have to cross the x-axis to get to the hole. So I know it's going to have to start up, come down, hit that hole, and then go back up. Because again, I know it has to go back up because it's not crossing my x-axis. Now the other side, they kind of have to play a little game. I don't know if it's going to be above or below this. All I know is it's not going to cross again. So I have to pick a value and plug it in. So this is -3, so I'm going to pick, let x be -4. Okay. If I plug in -4 squared is 16. -4 times -5 is +20. -4 cubed is -64. Plus -4 squared is 16. 6 times -6 times -4 is +24. Ooh. I don't know why that hurt my head so much. And really, we only care if this is going to be positive or negative. So 16 plus 20 is 36. Divided by 40, so -24, I think. But either way, it's going to be negative. So that means it's going to be down here because it's just a rough sketch. So we just draw that. Then again, I don't know if this is going to start from above and go through that intercept or start from below and come through that intercept. So again, I just pick a point. I'm going to choose 3 because it's my smallest next to it. So 3 squared, if you look back at your equation, so I'm going to let x equal 3. 3 squared is 9 minus 5 times 3 is 15. 3 cubed is 27. Plus 3 squared is 9. Minus 6 times 3 is 18. So then I get 9 minus 15 is negative 6. I'm going to do this part first. 9 minus 18 is negative 9. So 27 minus 9 is negative. No, it's not. 27 minus 9 is positive. 18. Positive 18. Jeez, I'm tired. So again, it's a negative number. So that means, oh, it's going to be down here. And it's going to go through and have to go like that. So that's your final sketch. Hopefully this helped. It was kind of sporadic. But that is your answer.